What is up, guys? Welcome to the PySpark tutorial series 2024 for beginners. I'm AJ and today we're gonna talk about how Spark code executes within the Spark architecture, and second thing is how we're gonna manage memory and configure Spark jobs while submitting jobs into the Spark cluster, right? So these two are overall agenda. So before starting, this Spark should be installed into your system. Without Spark you cannot run any Spark jobs. So if not, then you should check out my first two videos of the series. I have covered everything. I have covered how to install Spark, Java and Python on MacBook and also on Windows, so you should check that out. Okay, let's begin with our video, right? So in this code, as you can see, what we are doing is we are just importing Spark session from Spark, like PySpark.sql, right? The Spark session is the most important because it is the entry point to the programming with the Spark, right? And it also allows you to create data frames and you can execute like a lot of SQL queries, right? I have already mentioned this in my previous video, and today I'm gonna link it with the code, right? So it will make more sense to you guys. Okay, so first thing is creating the Spark session. So first function we are using here is Spark session.builder, right? And then we gonna put the name here, like the app name, whatever you want. I have just added here like code with AJN, and then for creating the session you just need to call this function, right? So this session will be used to interact with the Spark cluster. Without this session you cannot perform any job into the Spark cluster, right? So, and also just to show you guys, I have downloaded this CSV file. So if you want this, then I can share you into the description, but this is just a random CSV, right? So this is only for testing purpose. So what I'm gonna do is I'll try to read it into the Spark. So spark.read.csv, right? So this is the function to read CSV, and then I'm gonna put the path here. So to get the path, I'll be copying this relative path, right? So this one, and now header equals to true, and infer schema. I'll be covering this whole so no need to worry. I'll just start the whole code. Okay, so here first thing is like we are reading the CSV file, right? This is a relative path. Relative path is from where you're reading. Means if the file is into the same folder, then the relative path is just the file name dot extension. But if there will be like something called files or test files, right? And then if we are copying this here, move, then the path name will be test files slash csv.csv, right? So this is how it is. Not like too much complex, only the simple raw path what we are giving. And now second thing is this header equals to 2. This parameter indicates the first row of the CSV file contain column name, right? If you are not giving this header, then it won't take column name. So I'll be showing you how it will work without header and with the header, right? And also this infer schema, it will automatically takes the data type if mentioned, like if the d types is already been added up into the metadata of the file. If not, then it will take all the columns as a string, right? So what we're gonna do is we'll be just doing this df.show, and then we'll be running it. So to run, I'll be running as normal Python code, but it will be capturing everything. It will run as a Spark job only, right? So see, so yeah, so see, so like it have taken the column names whatever is there mentioned in the CSV file. So you can see this is double type. Okay, let me check if it have covered schema also. So okay, so yeah, so see, so it has the schema information also, as age have double type, height is also height is also double type, and weight is also double type, right? But what if we will give this false and this one also false? Now what will happen is, it won't take the column names, it will take the column name into the second row, like from the second row, and the first row, as you can see, like that is highlighted, like that has been highlighted here, will have like 0 1 something, right? It won't take column names. Now I'll be running this. See, string, so yeah, so see, so this is how it will take if you won't give the header. And infer schema is also, see, so it will consider all the columns as a string if you won't give this as to take the schema from the file itself. We need to put this parameter as a true, right? So I'll be adding some more here, like some kind of like filter. Okay, so let's try with some filter here. So what I'm gonna do is df where. Now where is a SQL function. You can write this where clause directly into the like using the df like Spark. So basically this df is data frame type, right? That is why we are able to data frame, yeah. So that is why we are able to use like execute this where clause directly, right? Because as I have already mentioned in my previous video, Spark gives a leverage to execute SQL query directly onto the data frame. We don't need to use some other tools for the same thing, right? So what we're gonna do is we'll try to filter it using the age. See, directly just whatever like it is a simple SQL you need to add here. Like as you can see here, we have this age column, this one. So we need age greater than 40, we need everyone, and now we'll give this data frame variable name as senior, right? Okay, so and here df junior, and then df senior equals to df. I'm just doing some random operations, so no need to worry. Sex and then age, right? Now we'll print df seniors. Okay, so let's run this and see what it will give. Oh, this is an error. Okay, so there are some issues with the column name. Oh, age is of caps, so this also is one error. Hopefully it won't be having more errors here. Okay, let me do one thing. So I think a lot of issues are there in this. Uh, okay, and now each cannot be resolved. It has each. Each. How to replace? Oh, here. I'll just replace this. We don't want any spaces. Let's try it now. Okay. Okay, so now it is working, right? So as you can see, we are getting all the ages that is bigger than this 40. Okay, so like this is how is like too much simple to write the Spark code, right? You can do the same thing here, right? now we'll try to write the same output into some CSV file, right? So tf senior dot write dot. Okay, let's try with Parquet. I'll give the same path here, and then that's it. I will run here. Okay, path already. Oh, sorry. So here it should be Parquet. My bad. Right. So it will create the Parquet here, and as you can see, it has two partition files. We can change it also. We can do something like df senior dot repartition. But okay. So but that is something I'll talk about later, but you can try this out by like single partition. We don't want more partitions, so just try to run it here. And okay, so here mode goes to override. As Parquet is already there, we'll start the mode to override the same file, right? So it won't clash or it won't throw any exception. See, now it will be having only single partition. Yeah, this one, not CRC, only this single partition, right? So now what we're gonna do is, well, okay, I'll try to explain you now using this code into the architecture, like how it will execute, right? Okay, so first thing is Spark session. As I yeah, here as I already mentioned. Now what it will do is, as you know, that Spark session is created here, here only. 1 second. So this Spark session is here. So Spark session is being created. So as we already seen, like this is the entry point that will interact with the Spark cluster, right? It allows you to create data frames and execute all the SQL queries, right? Like whatever queries we have executed here, these queries, these are SQL queries. And how we are doing this? So Spark give this using this Spark session. So Spark session gives us leverage to execute SQL query into the Spark cluster, right? Now second thing is the driver program. So the driver is the main control process. Like this is the main one. This manages the execution of the application, right? This one. So this manages the overall execution of the application, right? So and also this will create the Spark session. When we did that Python and that file, right? So this one, when we executed, when we entered this command, what happened is the driver starts the create the Spark session, right? And it will coordinates the execution of the task, like how task gonna execute, right? So this will be onto the on the head of the driver, this one, right? Now the third component is cluster manager. Now this cluster manager it will manages the resources across the cluster, right? So when the Spark session will get created, now the cluster manager will allocate the resources or the memory or the RAM for a job to be executed. And how this is gonna happen? This will be happen using the Spark session, right? Spark session gonna interact with cluster manager to give us the resources. Now example for the cluster manager is, as I already mentioned, it is like yarn and Mesos and Spark's standalone cluster itself, right? So these three are the just example for for example, I'm saying the names. So these are the cluster manager, right? So it will manages everything. Now the fourth component, as you can see here, is the worker nodes, right? So worker nodes executes the task whatever driver have assigned, like whatever the driver have assigned to the worker nodes, it gonna execute, right? They process this worker nodes gonna process the data and result and return the results to the driver back. Like whatever results will be there, it will return to the driver back, right? Now how now what is the role of this executor? This executor are the processes running on the worker nodes, right? And this executor executes the individual task, like whatever task has been assigned, it gonna execute those tasks, right? And also each executor, this executor and this executor has its own memory, right? And also these executors manages data and task execution, right? So just to recap, we have this Spark code here, right? This whole Spark code we have this one, right? And now this Spark code we have placed it here into the driver program to run it, right? Whenever we give that command, that Python 3 and then test.py, it will come to the driver program, right? And then it will create a Spark session, and then Spark session will interact with the cluster manager and it will get the resources, and then the worker nodes will get created, right? And then what happens is this driver node will interact with the worker node and will assign the task S1. As we have already talked about this, like it will be this Spark code or this Spark session will create the whole process or whole application, like whatever needs to be executed. It will create a DAG for it, right? It is just a transformation or action. If you have given any transformation or action, as in our case we have given this select, this select one, this select, and this where clause we already have given. So these are the transformation and actions what we need to do. And also this action also, this Spark it we already have given, right? So now what happens is it will create a DAG, right? DAG is nothing, just a stages. Okay, so first one what to be executed, second one what to executed, third one what to executed, and fourth one what to executed, right? So suppose 4 stages is been created, right? Now it will go again to the cluster manager, and through the cluster manager, driver will like distribute the task, right, into the worker nodes. And this executor will be having 2 tasks, and this executor will be having 2 tasks. So this thing is managed, like this whole process is managed by driver using cluster manager, right? So in like within the Spark architecture, this way our code gonna run, right? Okay, so the next thing what we're gonna talk about is memory management. Okay, right, so we already have created the Spark session here, but now what we're gonna do is we will add just small configuration just to understand. Spark.driver.memory, and then we'll give one second. So here we'll be giving only 2 gigs, right? Yeah, so what we are saying here is for the driver side, just give only 2 GB of memory, right? So now it will set the memory for to 2 gigabytes, and the rest of the memory will be allocated for the executors, right? And as you already know, the executor has its own memory, which is been divided into storage memory, right, for caching data, and also for execution memory, like as an execution memory, right, for shuffling, like for shuffling and sorting of the data, right? So now you can configure this executor memory and also the number of executor you want to use, right? So now what we're gonna do is we'll add like 2 more config here. So Spark dot executor dot memory so 2, I'll give you I'll give here 1G, and then dot config Spark dot executor dot instances. Here I'll say 2 instances, right? And one more we need here. It says core. We don't need on the local run, but I just want to make sure that you have the basic knowledge, because on the cluster side, when you gonna run on the main cluster or the EMR, then you need this kind of then you need this kind of memory management command, like you should know, right? So spark.config.executor and then .cores, how many cores we need. So I think this MacBook have only 8 cores or 4 cores, I don't remember, but I'll give here 2, like just not to crash, right? Okay, so we have driver memory as a 2 GB, executor memory as 1 GB, and instances will be 4. But why it is giving? Oh, error. Yeah, right. So okay, so I'll try to run now everything. Okay, so what we're gonna do is now here is we'll just add the spark stop command, right, in order like not to have any crashes, right? Okay, so let's try to run this. Right, so this is how we can check, means this is how we can configure the like our the memory and the executors, right, before submitting the Spark job into the cluster, right? Okay, so I have shown you like how we can like how the Spark code executes into the like within the architecture, you know, like how components interact, and second thing how the memory will be managed, right? So we have covered the basic of the PySpark and its execution, right? So understanding the architecture and the proper configuration is the key of making most Spark powerful data processing capabilities, right? So so yeah, so this is it. So thank you for joining, and please like and subscribe to my channel. So happy coding, and bye bye.